An example now, sometimes called the type 3 example. I'm not going to stress much about that. I'm going to say an example in which we find that we are using the co-ratios, right? So here's one. I've got cos of x plus 10 degrees is equal to sine of 30 plus 2x degrees. 30 plus 2x degrees, right? So 30 degrees plus 2x. Now, when you see an example like this, how do you know what to do? Well, you can turn this into a type 2 equation of what we've looked at previously, right? Where you try and turn it into the same function. So here, I want you to look at this. I've got a function, okay? In other words, I've got a ratio, and then I've got an angle, or given angle, right? And then over here, I've got the co-ratio, and then over here, I've got another angle. Now, this is not the reference angle, but we can turn it into the reference angle. And how can we do that? Well, we rewrite this into using the co-function in order to make the arguments of the functions the same. So I've got cos of x plus 10 degrees is equal to cos, and that's in the first quadrant, right? So you're going to say it's 90 degrees minus this angle over here of 30 degrees plus 2x. And why can you do that? That's co-functions, people. That's co-functions. So all we do is we say this is equal to cos of x plus 10 degrees. And that's going to give us cos of 90 minus 30. Well, that's just going to be 60 degrees, right? Minus times the 2x, so it's negative 2x. Okay, and now we see it's in the form that we've previously seen here. We've got a ratio and the same ratio, and then that's my given angle and that's my reference angle. So using that form, we can now identify that this is going to be reference angle, and this here is going to be my given angle, right? Okay, and I've got the same functions. Now, this was positive. This result over here was positive, so the quadrants that I'm going to be working with is the first quadrant that I have to solve for, and the fourth quadrant. That's what I'm interested in, looking at what I've got. Now, the reference angle is also something that can easily be seen. The reference angle, which is R, reference angle is equal to 60 degrees minus 2x, okay? And now I can solve. And when I solve, remember I work in two quadrants. I'm going to solve for the first quadrant, and I'm going to solve for the fourth quadrant, which I'm going to do over here. So, first quadrant. We take the given angle, and we make it equal to the format of the reduction formula using the reference angle. So I'm going to say given angle here is x plus 10 degrees is equal to, x plus 10 degrees is equal to, in the first quadrant is just equal to theta, which is going to be the reference angle, which is 60 minus 2x. And because I'm working with the cos function, I say plus n multiplied by 360 degrees. Now I get all my x's on one side, all the others on the other side, and I see, well, this is going to be 3x is equal to 50 degrees plus n multiplied by 360 degrees, such that n is an element of the integers. And here I can simply simplify this and say divide everything by 3, and that's going to give me 50 divided by 3, which will be 50 divided by 3 has to be 16,6 something. So let's say 16,7 degrees, right? Plus n multiplied by 120 degrees, such that n is an element of the integers. Okay. Now, I haven't shown you guys how to do specific solutions just yet, but I think that's also something that you guys will catch on very quickly. Now, on this side, and this side, I'm working in the fourth quadrant, people. So I'm going to take my given angle, and I'm going to say x plus 10 degrees is equal to 360 degrees minus the reference angle in the place of theta in the reduction formula. So I'm going to say that's equal to minus 60 degrees minus 2x. Okay? Plus n times 360 because I'm working with a cos function. Now, let's simplify this. 360 minus 60 is 300. 300 cancel out with that, so that I've got 290 degrees. That's going to be positive 2x, which I bring over is minus 2x. So this is going to give me a negative x on this side, right? And That's going to be plus n times 360 degrees. Okay, so now I want to solve for positive x, so I can divide everything by negative 1. Fairly trivial, fairly simple. And that's going to give me x is equal to negative 290 degrees minus n multiplied by 360 degrees. And don't forget, I have to state a restriction here such that n is an element of the integers. Okay, so that's your third example for general solutions. Okay, so we're going to do another 5, 6, or 7 of them, and we'll also point out where they deviate from these common types of general solution questions.